good. Okay, then take two. Shot one, take two. Let's go.
Yeah, okay. Hi, good morning. My name is Eyal. We've met last time over here. And today I'll do kind of like a second part to what we've done last time, which was projection with, instead of Nuke, the 3D-ness of that and what we can do with that a bit more. Today we're going to focus on shadow maps. I don't think we have time to do reflection as I mentioned on the email. Yeah, I'll just go over it slowly. One second, I'll just do it. Okay. And where are my notes? Sorry, I just gotta have everything set up over here. Yeah. So shadow map, as you can see over here, I have a teapot over here and a card, and a shadow map is basically what's causing the shadow. Shadow map is basically a technique I'm sure most of you know, so I'll just say a few words in the case some don't. But it's a technique from gaming mostly. It's in the world before we have in the rasterizer world, before we had ray tracer or path tracer, we needed a cheap way to do shadows. So I'll just go through a basic setup just to see how we're doing something like that. Then we can try to build up on that, see the limitation, what we can do with that as well. Yeah, so I'll just bring a teapot. And one of the notes from last time someone told me is that they want me to do it one by one, so we can see exactly what I'm doing. So that's what I'm going to try to do this time. So I have a teapot over here. And I'm going with the same camera of the scene and same card actually. Oops, sorry. Where is my card? Okay. So, so I have basically a card over here as the ground. I have a teapot. I have a camera. Let's bring a scanline renderer. Yeah. Oh, okay.
I'm curious.
You're curious? Okay, that's good. Hope it's okay that I'm doing it slowly one by one so we can see what I'm doing, but maybe it might be a bit boring. Let's go. What I'm going to see, I have to bring a light as well. I'm going to bring the light over here, the same light that we had before. And diffuse, so we can see the shading. And I'm getting a weird result. What am I doing wrong?
Are you inside of the teapot?
No.
The light?
Sorry, yes, you're right. It's the camera. I need the camera of the light. Sorry, it's this guy. Absolutely. Thank you. So I have this guy. Now I have basic setup. I'll just do the normals as well just to make it softer. I'll do, sorry. Is it set? I don't know, sorry. Build. There you go. So I have a basic setup. Now I'm going to do this shadow map. Now if you remember from the last one, it's the same technique as before. I'm going to put a camera where my light is. The last time we did basically the camera where the ground was to get this kind of like ambient occlusion effect. Now I'm going to put it where the light is to get the shadow map. So it's the same idea. And I'm going to project it on the card. So pretty straightforward. I'm going to bring another scanline render. I have the light over here. It's in the scene over here, so I can actually see it over here. Okay, that's what we're actually seeing. In this case, I already have the camera. It's supposed to be the other way around. Basically, I can put it like that, and the camera would be connected to the light. But in this case, because the way I built it before, the camera is actually what's leading the light, but it doesn't really matter, as long as they're in the same place. I'm going to connect the camera over here, and I'm going to render this guy from this angle. So we have these kind of things. And I'm just going to open it a bit so we can see what we're doing. Okay. And all we have to do is just project it. Okay. We have a camera. And I'm going to apply material over here. Like that. And I will combine them. Oh, sorry, not on that. On that. So actually we already have this shadow, nice shadow over here, but we can't see it because it just goes black because this output is just black. So to get the right result, I will just do merge material. Oops, sorry. Merge material. And I will combine this diffuse thing like that. Yep. And this is basically a basic setup of how I'll do it. So I'm looking through the lights basically, filming that, getting the output of the scan and render, getting a 2D input, and reprojecting it into the scene. Very straightforward. So that's our starting point. And again, the reason that we're doing that, I know we have now there's ray tracers and different techniques, and even Nuke has its own shadow maps, which actually going to work the same way that what I'm going to show you right now. I just want to break it down so we can see what we can do with it a bit in a more advanced way. So in case you already know it, this is how we do it, and in case not, this is how it's been done. So very basic setup. So the first step that we can do.
Second, I want to ask guys if you're getting this idea of camera actually projecting the shadow map on the card, because like we that's exactly what we wanted to do. We wanted to we said like, okay, let's try to do it very slow, because I know by myself how for me it was like to get it in beginning, like was not very kind of like understandable. And right now for us it's like, oh yeah, of course we're doing this. So the question if it's that was kind of like understandable for you how we created actually shadow now with the camera was clear, right? We can keep going, because otherwise we will lose you for the rest. Yeah. Okay. Cool. Then.
Yeah. Is everything? Can we see them all?
No, because we're presenting.
Oh, okay. And yeah, I think it was important to actually kind of understand the concept. But this is again, if you guys, I don't know how many of you been last time, but it's the same concept as this. So I think I told Alexa as well. This concept was kind of like very straightforward to think about projections like that. But when I first started to use projections, I didn't have any reference back then, and I couldn't connect the two dots between camera and projection, even though today it's obvious. I couldn't understand. I thought projection was just to put textures on things, and the link in between camera and projection, and basically the two sides of the two solutions, one is like input, one is the output, really helped me kind of like develop more tools for that. I think that's what Alexa is kind of like focusing on, like just to get the connection between what we're seeing and how we're projecting that. So this is what we've done last time it was here. And again, it's again this notion of basically we have this kind of like camera somewhere, it's seeing this image, it's reducing that into 2D, the FBD scene into a 2D scene, and then we are basically reprojected on the floor in this case. Last time we did it as an ambient occlusion, so we were connected to the ground. This time we're connected to the light, but it's the same concept. And the notion of the camera is to reduce dimensionality from 3D to 2D, sorry, and then reprojected that into a 3D element. So that's why I have it open again over here, but it's the same concept, the connection between them. So does that make sense to you? Yeah? Okay, cool. So I'll close this one for next time. So first I'll just talk about some very basic idea about like if we can just a bit optimize some things. And as you can see when I was playing with this guy, because, so I'll just go the basic thing that I've done before. I have again the teapot over here, I have the transformation separate in this case, some normals to smooth it out. I'm applying materials to just get this diffuse. In this case I'm controlling the render size over here, so this is just for me to get an easier control over scale. I'm projecting it again, and in this case I'm merging two projections on the card and getting the same result. So this is the same thing. In other real world cases I would actually flip them, but this is fine as well, the camera and the light. So in this case, just to get a bit more optimization, as you can see, I have just the teapot somewhere in the frame because of where the light is. In this case, I would add first of all a lookout. So I would put basically an axis where the teapot is. That's why I have this. I can actually connect them now. And if I will just do it like that, now of course it would look at the teapot over here. So now as the teapot would move in space, I would always get locked on it. So I won't have to waste a lot of rendering space, which is kind of like very straightforward, of course. But the second trick is, I used to do it a lot in Flame that I really liked, is when I have a model and I wasn't sure about the FOV or the focal length of what I want to do, because sometimes you go further in, sometimes further out to get the right thing, but then you always want to get the teapot somehow in the right scale of the frame. So I have this trick over here. I'll just show what it's doing over here in space. Let's do it like that. Oops, sorry. So I have a camera somewhere over here in space, and as you can see, it's actually moving in as I'm shooting that. But as you can see over here, it always stays almost in the same size in the frame. And the trick is kind of like a trigonometry of how basically the relationship between the focal length and the aperture size work. It's very straightforward. This guy's just animating the camera to go in and out. But this guy, the trick is, as you can see, I have this guy over here that's been linked to where it is in space. And this guy is just an equation of, ignore these words over here, world metrics, but it's basically just an equation of the distance from where we want to keep the same size. So let me just kill this one. I'll copy it over here so we can see the equation. And I'll do it like that. Okay. This equation just, let me replace it with something more readable like that. It's just x, y, and z. So this is just a distance equation. It just tells us how much something is far from an origin or from something else. In this case, from the origin, from the 0, 0. Which is this number, of course, over here, as you can see. So it tells me that the camera is 277 units from the world, from the 0, 0. And this guy, when it moves, actually keeps always the same size in the 0, 0. Let me show you what I mean. I'll go over here. Actually, to the origin. It will be easier if I go over here to the origin. Yeah. And if you look at the fast RAM over here, which is this guy, as I'm moving, oops, like that, you can see that actually this center area always stays the same size. So it's going to give us a pivot. So no matter how much I'm going to move in space, it will always keep this plane always the same size in the renderer. And that's why I can basically just move as much as I want. Now, just to see exactly what we're seeing, because it might be confusing from here, I'll put a diffuse over here so we can actually see the result. And I'll put a light as well. Yeah. So as you can see, as I'm moving, getting farther away, this plane at the 0 is probably going over here somewhere. There is a plane over here at 0, 0. It always keeps the same size as the rendering element, no matter what the camera is. And this kind of automatic process that gives us always the same scale. So again, we can kind of like even make this frame even smaller. I'm controlling the size of it. If it would be just one, it would be kind of like small. So now this focal kind of like give me a zoom that I can keep as a constant. So if I do it like that, it will keep this constant and so on. So just putting the number over here will just give me the right scale that I want, and I can forget about it. This comes from basically trigonometry. It's the ratio between, it's a linear relation between the focal and the aperture, which is kind of like this triangle. And changing this as we get in closer would kind of like change the ratio between them to always keep the same size in the outcome result. If you have an F or V, like in other software, I used to have it in Flame, we have to do this kind of like extra trigonometry. We have to convert this focal, which is just a distance, into an angle. So it's just an extra cosinus step, but it's the same concept as well. You have to do it, if you have to do it in Maya or whatever. So does that make any sense to you?
Yeah, that's kind of that pulling pushing in the real world, right?
Yeah, exactly. Like zooming out as you push in, or vice versa. And this just gives it the right ratio between those two. So you don't have to think about it.
Is it way more complicated if you have two objects in space? Because right now we are
Yeah, it is. So I have this guy over here, this lookup. As you can see, in this case, it doesn't connect to the guy because this kind of like allows me to, as you can see, I didn't put it in the bottom of it. And this kind of like gives me control to roughly where I want the plane to be. So clearly, even in this case, we are only aligned to a specific plane. Like it's only this plane over here, the 0. So even that is not really giving me, as you can see, when I'm going really close, of course, this part of the teapot is actually even going outside because it's farther away from this plane. So it's only aligned to a specific plane in space. If I had a proper maybe side view, can we see it maybe better? No, it's the front one. Yeah. So just to see that only in this somewhere plane over here, I think it's probably this one, the lines are kind of like pivoting. It seems like it's kind of like this one. It's kind of pivoted on that. Everything outside of that doesn't relevant for us. And it's going to be a limitation in a lot of places because we are again reducing it to 2D dimension, and it's going to cause some issues and whatnot. So we're just mimicking things. Okay, So third step is if we can actually add some maybe softness to the result we have over here. As you can see, I've added some softness over here to our teapot, and as the camera is moving. And honestly, just to do a very simple trick, I just put an axis on top over here, and I just gave a random noise on that. Now this basically is driving the camera, if I'll do it like that, to move like that. Now it's doing it if I look at the curvature over here. It's actually, sorry, not in the curvature, I want to look at the curvature. You can see that inside of every frame, not just when we're jumping between the frames, even just inside there is a lot of movement. So it's kind of like jitter a lot. And it will keep it, because it's in the origin, it will keep it roughly in the same position, but will move it. And if I'll go over here and just add motion blur at the render, I will just get this kind of like jittery result that, because this is close to the bottom for what we're doing and the origin of the randomness is the bottom, it will keep it sharp. Everything that is farther away, like those kind of 2 points, will get more blurry and soft, and we can kind of like get this cool result.
Cool.
This will be actually on 1. Yeah?
So just a quick question then. So that means that basically what you're creating is kind of subframe information?
Yeah, exactly. That's exactly what we're doing. Yeah, I will probably go back to that concept, but yeah, it's very powerful in a lot of cases. Like in a lot of cases, when I have to do like maybe split results on an output or stuff like that, I would do a lot of things on the subframe result, then I would merge them again. So yeah, sorry, Adrian just threw me off. So you can play with that, and this is the trick over here. I want to talk about more of this concept of the jitterness to solve this problem, because as you can see, I'm using over here 110 samples, which is quite a lot, even though this result is kind of small, which is more than we need. Probably it's still not fully perfect, so I want to see if we can actually slightly make it better. And last time I was asked why am I using orthographic versus perspective, and actually I want to bring the photos that we have over here, and I will just try to address those things very quickly. Yeah, so this is the trick that I was saying about the focal length, the ratio between the focal length that we're changing and the aperture. That's what I was trying to explain before, and how is it changing, so it will kind of like keep the same ratio all the time. And it's basically this kind of like sampling thing. So in Rasterize the World in the past, I think also Nuke in the past is to use this technique of basically sampling every X amount of time subframe, kind of like different motion, and then it will add them all up to get the motion blur, and it's called, I hope I'm saying correctly, stratified. Actually, right over here, yeah, stratified, which kind of like means evenly. I think nowadays this term kind of like changed. Now in rendering, is even Nuke as well is just doing kind of like this noise, kind of like random, kind of like sampling to get it kind of like more even, which is more in a kind of like, it's a new technique that we're doing. But in the old world, you can see, if you remember, you used to get this kind of like sample things. And I want to try to do the same thing. Instead of using a noise technique, I want to use the same technique as it's kind of like this technique, evenly sample a camera space, and then to see how we get this result. I'm just going to say that about perspective versus orthographic. So last time that I was asked about it, I just want to focus on a little bit. I was talking about that orthographic for me was trying to align how a plane would see something, as this is what we were trying to do before, from the ground or from the stairs, and how it would view it. So that's why I use this orthographic. The lines of that, because it was parallel, was aligned to the plane. In this case, we want to get a perspective on not parallel lines, because if we think about it, lights propagate in all directions evenly. So it's kind of like mimicking the perspective. So if you look at this kind of thing, let's say this is a light, it would propagate in all directions. In our case, the camera just take it a chunk of what the light would propagate in this direction. So that's what we're trying to mimic. I don't know if it helps this concept, but we kind of like, this is the difference of what I'm playing with over here. And in the real world, another thing that I want to mention, I don't know how much people feel comfortable about it, point lights, which is what we're doing over here, or parallel lights don't really exist. They're not physically correct. They're just a reduction of physicality. The reason they don't exist is because light is not parallel. There is nothing as parallel or directional light. It propagates in all directions. And light is not point light because it's not infinitely small. And this is important for us, because all light have some surface basically to it. Maybe very, very small, like a LED light, or very, very big. But it's an important concept because the size of the surface of the light dictates how blurry the shadow would be. So the bigger the area of the light, the softer it is. The sharper, or the light source is, basically, the sharper it is. And you can see it basically with sunlight and none overcast day. So if it would be basically a sunlight, we have just a point light in sky and we have this sharp shadow. If we have overcast, which means basically we have a very massive area light, which is all our sky right now, that's basically light almost evenly the same subject. So we have this kind of like thing, and we can think about it as basically having like a lot of source lights in all direction, light in our thing. So I'm saying it because this is correlating to me trying to do a blur over here randomly, and me trying to do something more correct with controlling the area light of how much blur I want it to be. That's why I'm trying to connect those dots. So in order to do that, is it this one? No, this one. What I'm doing, I'm just showing, first of all, is just a basic idea. So let's say I have an area light, which is just a plane, a basic plane. And what I'm gonna do, is it this one? Yeah. I created this kind of like trick that I have this transform over here. And I'm giving it a grid 4x4 in this case. And what it will do, it will go and just go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And it will basically move a camera in this area light to basically sample it from, in this case it's 4x4, 16 times in this kind of like sampling area. But I'm gonna do it in all sub-frames, so all will happen in one frame, all of those 16 samples. And this guy will just control that. So to see it in 3Dness, let's say I have this card, and let's just think that this is our area light right now. I placed it in the same places where the camera is, in the center. Okay. Let's look at that, sorry. Yeah. And I've divided it by 4x4, that's just so it will align with what we're doing, but we can play with that. So let's see the result over here. And if I'll swap between them, I think it's this one. Let's see if it's the same. Is it 4x5? Yeah. So as I have this grid over here, basically what we'll do is something like that. I have this, it's the same formula as this, it's just jumping based on, I'm giving it this kind of like grid. Area size will tell me how much my area light is, which basically dictates this guy. How, actually I can connect them too, which I should have. Yeah, like that. So this will give me the area light of what I want to do, and this will tell me the samples of how much I want to slice this card, how many samples I want to have per area light, just to get more defined. And it will go on one by one and just sample it or photograph from this direction, and this is how we'll get different angles, small different angles, combine them all together with the motion blur and get this kind of like defocus effect. And one thing to remember is that I'm breaking two cameras, so one camera would actually do that, but it will do it under one frame. As you can see, you will not see it moving over here because it's happening in the subframe. All, if I'll show it over here, just so we can be sure. Curve, yeah, everything is happening right now in a subframe world. So, as you can see, this is one frame over here. It will sample it 5 times over here and on the Y as well. And this will give us the effect that we want. But then, I want to have another camera to reproject it again on the plane. So I'm only going to do it on the shadow map, just to cut corners. And this camera should not move. It should stick to the center of the world, unlike this camera that is kind of like moving around. And that's why I have those two cameras over here. Both of them align to the origin of where I want the camera to be. One will move and would render for us the scanline. One will put the light in the right place and will project again. Okay? As I go to this result, I have this kind of like this effect. And as I go to this guy, first of all, I've linked them both. I have this samples is 5 basically squared. So I have 25 samples. As I go for more sample or less samples, you can see over here that it will give me these kind of things. So it will give me less samples, only 3 samples. As I'm going up in samples, it will become more and more, it will converge to the right solution or to the right result that we want to have basically, which is basically how renderer nowadays work. It will just try to converge, it's when we have noise. The stratosphere is what we've seen as the samples before, as I was trying to show. Now we have blue noise and different techniques to kind of like break it down, maybe per pixel or whatever it is. So let's see over here. And also I can control, as I said before, the area. So as I make the area bigger, as I said before, I will get a softer result for that. And as I go smaller, I will get a sharper result, which is what I said before about the ratio between the surface area of the light and how big and small it is correlating to the blur that we're trying to do. So it's kind of like more physically trying to emulate how real light would work. I haven't done over here, but you can think about the same result to create an ambient occlusion. We can take this camera, instead of just putting it on a plane, we can rotate it basically 360 degrees, basically on this side and 180 degrees on that side, sample it for, I don't know, 100 samples, combine them all, and we'll get basically an ambient occlusion from all directions. So it will give us a shadow map from all sides, combine them all up. So it's the same technique as well. It's a bit too heavy, I assume, but you can try to do that as well. So does this concept make sense to everybody? Yeah, okay. See, I'm seeing that in the head, okay. Yeah, is there anything else that you, any questions?
The expression for camera actually doing the grid.
Yeah,
I know
sure.
that it's kind of
Yeah,
like
exactly.
So the idea to do that, maybe I should just do it on Paint as well and try to explain. I'll bring them both so you can see how it works. Oops, sorry. This doesn't do anything. It's just for me to explain. And this is X, and this is Y. Okay. So the idea is, if you think about it, if we have, let's say, 4x4, our X should move basically, it should do 4 cycles, right? Because we have 4 rows by 4 columns. So it should do 4 cycles of 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Our Y should stay, basically should do only 4 cycles, but it should shift every 4 beats, like basically in music. So it would say 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That would give us basically the 1, 2, 3, 4 in X, and then Y would jump 1, 2, 3, 4, and then Y would jump again 1, 2, 3, 4, and so on. That's the idea. So what we're doing over here, we have an F mode, which is a modulate, and it's a cool trick to make something cycle if you don't know this equation. So if I'll put this frame over here, I'll do frame, and F is for, I guess, float in this case. Usually it's just called mod, but yeah. So I'll do, let's say, 5. Now it will give me a cycle of every 5 bits, which means basically it will not let any number on the first element over here of the frame to be higher than 5. So it will go through 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 5. It's kind of like doing dividing, but it's only giving us back the reminder. Okay, that's the idea. Actually, F mode is just the reminder of the division, if we want to get just the reminder. So if I'll go over here and look at the curve again, you can see that basically now we have this bit. It just goes, it doesn't change, 1, 2, 3, 4, 5, reach to 5, drop again to 0. It's basically kind of like dividing it over here with 5. So 5 divided by 5, it's 0. So now it's 0 again, and 6 divided by 5. So it's basically just giving us the reminder. That's what we get. So we're starting to get closer to the first bit, which is the X. And we had 1, 2, 3, 4, 1 or 5 in this case. So we have this X now. Now in the Y, it's a bit trickier. It's not trickier, but basically what we want to have the same kind of like cycle, but we want it to get stuck in one place. For 4 bits. So what I'm going to do, if I remember correctly, I'll probably not remember correctly, I would take this number. Let's see if I remember correctly. I probably don't. I'll do int. I just want to see if I'm is it like that. Yeah. So this gives us a steppiness. I think it's the other way around what I've done over here. But the idea behind this steppiness, I think it's the other way around. Let's see if I'm correct. No, other way around. Okay. Oh, that's right.
you just
sorry. Yes. Okay. Yes, that's what I want to have. So the idea between this int over here, or any other word that you want to do, maybe if it's round or whatever you want it to do, can actually see the size of the text, by the way, over there. Yeah, it's okay for you. So what I'm doing is I'm writing over here int, which is an integer. You are converting. We are casting from float element to an int, which means we basically drop the reminder. So fmod gives us the reminder, doing an int dropping the reminder, which is kind of like what we want to have. So one place takes just a reminder on the x, and the other guy is just not what the reminder and just stepping on that. So when I'm doing int over here, this dividing by 5 and times 5 kind of like give us the same ramp of time, but will give us the steps of what I want to have. In this case, I want to have every 5 bits only to jump on those cases. What happened over here, if we have 1, 2, 3, 4, 5, when I'm dividing by 5, it would scale everything between 0 and 1 up to here. So, and because it's int, it will all go to 0 in this case. Multiplied by 5, it's still 0, but in this case, it will give us 1 because everything now is between 1 and 2. So on the reminder, we're just getting dropped. We're staying on 1, 1, 1, 1, 1 times 5 in this case, and so on. So we get it 5 and then 10. Does that make sense?
Yeah.
Any questions on that? No? Itamar, go on.
Too much math. It's hard for me to follow.
No, it's not.
The integer is taking each frame divided by 5.
Maybe don't look at that. Maybe I'll do it over here. So just think about it like that.
I understand what it's doing. It's basically waiting 5 frames to go to the next step.
Yeah. So
how you got it? How you got it to do
5
with
by 5
is a different thing.
So if I have one, let's do it like that, and I'll do it. Okay. So if I'll do it 1, 2, 3, 4, 5. This is like, let's say, our first 5 frames, right? Frame just gives me 1, 2, 3, 4, 5, 6, and whatever. When I'm dividing it by 5, I get basically this kind of like 1 over here, and 8, and I don't know, say 27, I don't know, 75, I don't know, whatever, and 25. I can't remember in my head what it's supposed to be. Actually, 2.
Integers, it would be 0, 0, 0, 0, 1.
Exactly, as I'm doing the int. And then if I multiply it again, so now we get basically 0, 0, 0, 0, 1, multiplied by 5, now I get 0, 0, 0, 5. 6 over here would give me 1 point something, right? So now it's 5 again. Does that make sense? So that's the trick, basically. We are put it in the range of what we want to keep every 5. So every 5 would give me full integers number, right? Because it's going to be now 0 to 1, 1 to 2, but the whole number of 1 and 2 is now kind of like aligned to every 5th step. Doing the int will kill everything in between to an integer again. Now we can control if we want to have floor or ceiling, which means basically align it to the bottommost lower part of the two numbers, or the higher one. It doesn't really matter. Int gives us the lower in this case. We can do our int. It doesn't really matter. It depends on what you want to do.
And to that, you're adding the F mode again.
The F mode is in this case I only done it because I'm doing everything in the subframe world. So this is just the concept. I'm doing slightly different over here. This is our scaling. We want to do it between -1 to 1, or between the range of the sample of the area. So this is what it's doing, this part over here, and it's this part over here. And in this case, it's a bit tricky. I'm not going to go into explain that, but basically, really to align it to the right samples, I'm doing this thing over here. And this is the F mode. In this case, it's just to align it to be on a subframe world, unlike over here. Okay? Yeah, so everything would work in. Any questions on that?
I actually think let's keep going, because right now I think we have enough information to actually read this, and later maybe to understand completely, but it's
and we are way behind, but okay.
Yeah, it's all good.
Okay, so now I don't know how many of you have been last time, but I'm just gonna try to add everything up. So now I have this camera, and I have this kind of like nice, very beautiful, nice blurry shadow, and I'm just gonna add this a bit of this occlusion thing that we've done last time. So I'm doing the same trick. It's just a reminder, and it's the same concept. I'm taking this teapot, I'm filming that from the bottom, so where the card is, and I'm taking only the depth over here, which is this guy, and in this case I'm just doing a very simple blur on that. But as the teapot goes up in the air, it have an animation, it just dissipate and disappear. So this is just a reminder to get them like add everything all together up. If I'll do it is it this one? Yeah. So now we have this kind of like occlusion inside. And what I can do in this case, I've taken the alpha of this shadow map, and I've basically masked the occlusion to only be on the shadow side, like in the real world, almost. Well, a fake real world would do. So I'm kind of like sensing that to be only inside, and now I have this kind of like fall off ambient occlusion with the shadow. It gives this kind of like extra nice kind of like look to it. And I also added an extra light over here to get this, because otherwise we wouldn't get this kind of like bounce over here from the floor. So it's just to add up to what we've done last time. Any questions so far? No? Cool. So let's look at a slightly more maybe complex case. I'll just kill it from here. Yeah. So what if I have two teapots and they interact with one another? Because we all want to do two teapots. So this is a bit of a tricky thing, because if I would, so first of all, I have this render over here. I'm doing the same trick. Camera looking from the light. I have two teapots, and I'm putting it on the ground. So now I have this very nice, is it just this guy maybe? Yeah, I have this very nice shadow on the ground, putting the teapot on top, and we have this shadow. What if we want to have this shadow on top of this one? Well, I can just add it on top and we'll get a black. And it kind of makes sense. We're getting black because we are shooting this element as well to be on the ground. So now it's projecting itself on itself, just a black basically mask. So it's just filling everything up with black. We can actually see a bit of like where it falls off.
If you even put transform, I think here.
Over here?
Just and just scale it slightly down 0.00. You will.
Yeah, exactly.
Yeah, so we see that it's actually that's
Exactly.
what it does.
So it's still there, it's just kind of like filling everything up with black, right? So one very easy solution is to break it down into two different scanline render, which what we've done over here. So now I have one teapot, second teapot. They are both being combined over here into the card area, and only one of them, only the first teapot, is going to the second one. So now I have this very nice kind of like shadow on that. So if I move it over here a bit, can't remember which one is which. No. Actually, I move it from here. Yeah. So now I can have this nice shadow on that, and yeah, works nice. So this is one limitation. So if you're going to have a lot of objects, it's going to be a bit of a pain in the ass. I'm going to show a solution how to do it in one go in a bit, but this is the limitation of that. Second limitation is to remember that if I have a teapot that goes down, I think it's this guy, yeah, and if it's going below the ground, like in here, we're going to get this shadow in front of it, which kind of makes sense again, because we don't have the ground over here. We just have the teapot, which again makes sense. So in this case, the limitation to solve it is, of course, just to add a card over here, which is the same ground. I could have used the same one. So I would have it over here. But in order to have it, we're going to have to add a blend material over here to stencil it out. So get this result. So if I want to have it, I'll have something like that. The material would just basically stencil out this material from this material. So now we have these kind of things. Any questions? Cool. So now let's move on to this next part, which is self-shadow, which is how we can do self-shadow inside of that by ourselves. Projection does have basically, we can do culling over here, self, and it will give us. I want to show you how to do it by yourself. Again, to do some extra techniques. It's not connect for some reason. And it will try to solve some of the problems that we have over here. So in order to do that, instead of actually just using an alpha, we're going to actually extract the depth or the P world. So I have this teapot as before, nothing changed. And I'm shuffling out the depth over here. You can actually see it's the depth. If I'm going to do it like that, we can see we have higher values from here, lower values from there. I'm going to do reciprocal 1 over to get the real units of that. So we can still see it over here. So now I know that this element is 21 units from the camera, and this is a bit farther, it's 22, and this is a bit farther, and so on. So I'm going to have a depth. And I would project on the result. Okay? So it doesn't look like much, but if I'm taking it down, we can see that actually this already kind of like gives us a shadow, basically. And we can see that, we can think about it, that basically everything that it's been projected back on the same scene that it's been shot will give us the wrong depth if it's not aligned with the right polygon. So this will be the right depth because nothing is in front of it. but because this guy have this guy in front of it in the renderer, it cannot see it, it will project these values on that, right? So, does it make sense? Okay, I'll go a bit maybe slower. Just remember that this is a depth. I'll show it now in the p-world sense as well, because I think it will make even more sense. This is the depth. Let's try to plug in a p-world. So it's again saying I'm plugging out a p-world. I'm going over here, shader, position, shuffling it over here in the result, and I'm looking from here. We can see it even better. So what happening is basically this guy, right? It's getting projected by this value. Now you can think about it. I should have maybe made it. If we have, let's say, a few planes. Let's say I have one plane over here, one plane here, second plane, third plane, and I have a camera over here looking at all this scene. It will first, of course, only render this element because it's in front of all the rest of them. Projections don't care about it. It will project this value on this and on this. So let's say if it's rendering that and it has a value of 5 in the depth, it will put 5 over here as well and 5 over here as well. So now all of them have the same depth value as the rest of them. Sorry, as the first one. Now, if we were to compare the real depth, let's say it's 8 over here and 5, we know that it's obstructed by something. Because this value, real value is 5 compared with 5. Sorry, compared with 5. We know it doesn't occluded by anything. But this is 8 compared to 5, it's wrong. 10 compared to 5, it's wrong, and so on. So we're basically comparing different values. Everything that is not occluded will be the correct values. Everything that is occluded will not be the right values. And that's what we're actually going to do over here. I think I lost you all. Did I lost you all?
No, but we will get there.
Okay.
I mean, keep going, keep going.
Keep going.
We're trying.
Power through.
We're trying to.
So the idea is, if I have this projections of the teapot p-world, this is the real one. So I've taken the scan and render, again, shader. You can already see this is exactly what I just explained.
Yeah.
This is the real one, and it's just the real p-world, and this is the projected one from the camera. And we can see what the difference is exactly what's been occluded. So I'll go over here, and honestly, in this case, I'm just doing, again, the distance equation. So like before in the camera thing that I've done over here, I don't have it over here with the camera, this is just a distance. I'm just comparing the distance between those 2 points. Getting the result gives us a shadow, basically the occlusion inside of the material. And this is, well, self-shadow. So I'll just do these kind of things, and putting it back on top gives us basically a shadow map that is self. So does that make any sense to you? Yeah? Cool.
Boom!
Boom! Mic dropped. Okay. So one thing we can do with that, and again, I mentioned that projection have its own culling mode as well that you can use. It will have the same limitation probably. And scan and have over here when you're doing a shadow map. Where was it? I remember there was a shadow map, no? Right? Ah, in the light. Sorry, in the light.
Yeah.
No, in the shadow over here.
Oh, yeah.
It's, as you can see, if I'll do cast shadow, it has basically the resolution. And the jitter, it's doing basically what I just explained. So that's why I wanted to show you all of that, so you can kind of like follow up on what you're trying to do. The reason that I'm showing this technique is so you can play with it in a more precise way to what you need. Now, of course, in the real world, I would not use it like that. I would not try to light up a teapot. I would mostly use those cases when I'm trying to have an interaction with something that is on the set. And if I have the lighter, or maybe kind of like a digidouble or whatever, and this is where I basically would use that. So I'm not actually going to try to really do ambient occlusion or shadow. I will just try to add small amount of kind of like elements like caustics, shadows or whatnot, and I would use this kind of techniques. That's why I'm actually showing all of that. There is limitation to this, as you can see. If I'll show over here, the areas that are getting on the most side planes of the projections from our camera projecting point, which is actually this area of the teapot, and this area are getting a lot of errors. It's a floating point error, filtering issue, because if you think about it, we are taking these elements and projecting it on the polygon. So it means some polygons would fall between those guys. So it will not actually give us the right position area. So everything on the grazing kind of like angle, which is this guy over here or this teapot over here, will give us all this kind of like fucked up area. There is a way that we can solve that either by using normals or by actually just getting all the fall off area basically over here and kind of like eliminate that. I will show some things, but it is you to play with. It's a limitation based on how Nuke is written. There is a way to avoid it as well if it was written differently. Just to be aware, and you can see it over here on the result. So some things it's a bit. You can also, by the way, you can see an inner shadow from this lip on this, which is actually kind of nice. But some areas will get a bit fucked because it's again being distorted. One way you can see it also in the result because of that, because it's filtering simply different areas. It's also having an issue with how things are being sampled in Nuke world. You can see there is more error. There is more error inside of Nuke, and you can see even the polygons over here. It's just basically how it's interpolating the data inside the polygon itself, which is not the greatest way what it's doing. I think it's actually almost a linear interpolation, which it shouldn't be. So that's why we have all this kind of like errorness part of that, unfortunately. One thing that we can do with that is the result over here gives us a data. So if you look over here, it gives us data as we are getting closer to the right data. Over here we're getting smaller values because the disks between them are smaller. As the shadow are getting farther away from what is being included from it, it's getting higher. So we can actually use that to drive it to do some blurriness. So I'm doing the same thing, I have the same as before, but this time I'm just going to plug it into an eye blur. It doesn't have the name, but it's an eye blur. And this basically gives us, it's just using again the same thing that we've seen over here. I have this input which gives us 1.7 over here and 3 point over here. I'm blurring it a bit and dividing that so we can get a bit of the outside a bit for the eye blur. And this gives us a bit or a fall off on that. So if I'm trying to do that over here, it will give us a bit of a kind of like a shadow inside from this area. So again, we can play a bit with that, unlike the jitterness from before with the camera. Yeah, and we are basically doing a cheat that can help us as well to do that. By the way, I also wanted to mention that in the in this technique, it's also just mimicking something. It will have limitation as well because this is not aligned to the real plane over here. So if our teapot is going up in the air, which I think I've done it over here somewhere. Yeah, it does work nicely, but it's not fully aligned because our center, if you remember, the center of the camera over here is still aligned to, I think, this, which should not be. Which means if we are moving the camera, it have a pivot. So where the pivot is, it will be the sharpest. Everything that is outside of the pivot would be more blurry. So again, it's just an assumption, and we're just trying to get this result. So I just want to mention that as well. But let's go back over here to this eye blur. Last thing that I want to mention is just again, Itamar, for you extra math. I just want to show that you can also do it just with a depth. There is no need for P-wall. The only reason I'm showing that is because just for the extra points, if you want to understand how it works. And if you have a very heavy setup, sometimes it's easier just to get one channel instead of 3. So 1 depth instead of 3 P-wall. Also, it comes for free. Depth is always free in rasterizer engines. So in this result, what I'm doing over here, I'm just taking the P-wall, the depth, not the P-wall, and I'm doing 1 over, and so I'll get the real units, so 22. If I do it like that, we can actually see it as before. So I have basically this kind of like units, 21 over here and 22 as before. In this case, I'm just pushing it a bit outside to get slightly less error result. You don't have to do it. It's not really helping that much. And I'm getting the result over here. So this is our depth from this, not a P-wall in this case. And over here, I'm shuffling the P-wall from the real result. So it's not from here, it's the real thing. And depth is not distance equation in rasterizer or in most renderer. I think it's a bit confusing to some. It's actually the Z component of the P-wall. And it's not the same thing. This thing is kind of like spherical distance from things, and Z components will be kind of like a planar thing. And they're not the same values. They could be very close, but they're not the same values. So this is important for us. And when we are rendering, we actually render the depth gets the Z component, which means P-wall, if we can actually get the P-wall Z component somehow, we will get the right depth, which is what we're trying to do over here. So to do it, I have the P-wall, and I'm this I'm doing basically matrix transformation. I'm transforming from the real p-world of this element, which is this guy, to be the p-world in relationship to this camera. So I'm putting it in what's called camera space. Right now, this teapot p-world is in a world space. I'm going to render it as it will if be the right values from the camera space, this camera space, the light space. To do that, I'm pushing it with the values of the translation over here, and I'm rotating it, which is actually those values over here. I'm not going to go into it right now because I think it's too much trigonometry. You can just play with that. Doing those two tricks would rotate it to be how it will be basically from the camera view. So you can see we have a new x, a new y, and the b, which is flip, it's negative, I'm going to flip it again, gives us actually the right depth. I'll do it like that. And this is the right depth if I'm comparing it with the other depth. Sorry. How should we do it? Should I do it like that? It's a bit confusing because one is red and one is white, but if you can look at the values over here at the bottom, they're the same now. And the difference between them, like before, we're just subtracting one from the other. We don't have to do now a distance function, which is again cheaper. We will get again the same shadow. So now we get the same result with basically less rendering time. And I added an extra trick over here. It didn't work that well. I also took the normals. In this case, and rotating it to be from the camera space as well. Looking at the Z component, it gave me all the area, the grazing area of the teapot. So I can basically kind of like eliminate it from all this ugliness over here. It's not as perfect. You can see in some areas it's hidden too much, but it's an option you can play with, and it's an idea. So you can do some things with that. It's not perfect over here and here, but again, you can play with whatever you want. But this kind of idea solves some things that we can do. I think we have 4 minutes, so I'll try to do it quickly. The ground thing, so we have two teapots. Now we can only do it with one scan line. We don't have to do like two different scans, one for the floor and one for the teapot. I'm rendering again. I'll do it from here. I think it's projection. Yeah. I'm rendering the p-world of the entire scene basically from the light source, getting it outside over here. Shuffling out, so now I have basically the projection p-world, the real p-world over here, as you can see, and the difference between them give me everything, the self shadow, the ground shadow, whatever I want to do with that. I'm just compressing it a bit, and now I have basically this kind of like extra shadow, so it's all in one go. So this solves for us. Now we have even less rendering to do than before, so now we can add as many teapots as we want and everything would work. Also, it solved the ground intersection. This is a bit of a silly one because it will anyway do that in this case because, I mean, it's one over the other. But even if it wasn't, it's the same equation because it's doing a distance. So even if it's above it or below it, it will still give us the right shadow. So we don't have to do an extra work with that as well. Again, same technique, p-world, difference, and we get that. I try to combine now everything together. So now we have this self shadow, a bit of a bounce. Now I have this nice shadow over here inside. I didn't add the blurriness, but you can add it as well. And I think, yeah, this could go to the garbage for now. We don't have time for that. And this is just to show that it also works on a more complex object like this dragon. And we can have this shadow to work properly as well, and to go in one go and do all the shadows. Maybe I'll play it in the end. And again, I just want to highlight again that this looks a bit too extra convoluted and it's a bit messy, especially as I go along and try to build it in my head. I would not use it directly like that in the real world. And I think that's why I was trying to highlight as well in the setup from last time, that those cases are trying to usually to do interaction with the scene. I would not try to reinvent the wheel or try to do like proper ray tracer instead of Nuke. I don't think there is a point and they will do a better job than me. But they can do different tricks with that to get some interactions, and I think that's the key idea of that. And I want to say about shadow maps that in some cases, just 1 more minute, you can do more than shadows, which I don't have time in this case, but we can also emit in light from that as well. So you can use it as a light map. You can use it as a caustics map. In some cases, you would actually render what's called differ. You can render like different data from that, like the p-wall and normal like we did over here, and do different techniques as well to do from that. There is different paper from different, I think, NVIDIA as well, that they can use this kind of techniques to do a lot of shadows at the same time and different lighting. So it goes more than that, and I encourage you to play with that to see what we can do with that. Because this is not the idea to mimic what we have in ray tracer, just what we can do from that, what we can extract. Yeah. Any question with the 1 minute that we have left? Everything was perfect? Okay.
Okay. I got one question. So this is an example where you have a 3D scene and a 3D object. These kinds of techniques, how well would you say translates to a situation where you have maybe a 3D scene, but the thing that you need to use as an object is a 2D object, or basically, I don't know what.
You mean like if you have a plate of a green screen and a 3D scene?
Something like this, for example. So, how well do the technique?
So I had a real world case. I told Alexei I was trying to build it over here. I didn't have time for that, and I think we have time this time. I had a real world case in a project that I've done recently over here. Of a guy with a sphere like that, and it would put it on the ground over here, and it was supposed to emit light. I don't know if I can say it's from Dark Show, and it's supposed to emit light, and it's basically a shot of the legs of boots, and the lady just put the ball on the ground, and it emits this kind of like light all over the place. And I've done exactly this technique. I've done shadow map, but spherical one from the sphere, so it would emit the light on the boots. So what I've done, I took a very basic boots that we had it over there, roughly placed on where it's supposed to be. I just invented a camera and a booth, roughly to know how she looked like, and I aligned it to the sphere. It was a CG sphere as well. Got a shadow map of that, and then it was projected back on the boots. I added high exposure of the boots as well, multiplied it on top, and it worked perfectly and gave us this kind of like very beautiful lights. So it's kind of like a light map, not a shadow map in this case. That's what I meant before, and it worked really, really great. So to do even subsurface, these kind of things, and I have so many cases that I've done these kind of techniques to integrate things in the scene. Sometimes I would use just what I have rendered, and I would invent some p-wall and depth to get some sort of a 3D volume. Sometimes I would just use mask to put on something else. But it definitely, that's why I meant like it's a shame I don't have a real world example. I talked to Alexei about it. Those simplified examples don't give those techniques the powerful at how much they are. Like I've shown last time as well in the guy that leaves kind of like drops on the floor. It was a real case wall. I have a guy with a pen and I needed to do that. So definitely it works. I just wish I had something more to show how it looks like in the real world. Time. Anything else? No? Perfect? Okay, everybody's smiling. Okay.
Thanks a lot.
Thank you guys.
Nice job. Thank you again.
Yeah, thanks a lot.
Amazing. Thanks.
You're welcome.
Alexa, you're going to share the script?
Yeah.
Can we?
Yay. Yeah.
Yes, please.
Thanks.
So, okay. Ciao, guys.
Ciao, ciao.
Thank you. Bye.
Bye.
Bye, bye, bye. Okay. Just a second. I stop recording. Why I stop.